Hello students, welcome to We Learn Chemical Bonding and Molecular Structure. In this lesson, we will see about KÖssel-Lewis approach to chemical bonding. So before we move into that, let us see what is a chemical bond. A chemical bond is nothing but an attractive force that holds various constituents together. Okay. Here, look at this diagram. We have two atoms and there is an attractive force which binds both the atoms together. Okay, the attractive force acts between the nucleus of two atoms. Okay, how this attractive force can happen? Only by sharing of electrons. Okay, let's move on to the KÖssel-Lewis approach to chemical bond. What did Lewis picturize? He picturized the atoms in terms of a positively charged kernel. Okay, see, this is a positively charged kernel which consists of nucleus and the inner electrons, and he considered the outer shell as a cube. Okay, the cube has 8 corners, right? So he told that the outer shell can accommodate a maximum of 8 electrons. Okay, and if all the 8 corners are filled with electrons, means we can say that atom has a octet. Okay, it has attained octet electronic configuration. So octet means stable electronic configuration. Okay, there's a single outer shell electron of sodium. He has considered an example of sodium. We have 11 electrons in sodium, isn't it? Which only sodium has one valency electron. So only one of the corner of the electrons will be one corner of the valency shell will be filled and the other will remain unfilled. Okay, this picture represents the electronic configuration of a noble gas. Okay, all the 8 corners are filled with electrons. So thus we call it as an octet electronic arrangement. Okay, and Lewis postulated that the atom achieve the stable octet when they are linked by chemical bonds. So he has considered it can attain. So only noble gas can have a stable octet electronic configuration, right? But how the other atoms can attain this? Only by sharing of electrons. Yes, let us see the example. Sodium chloride. We know sodium has 1 valency electron and the chlorine has 7 valency electron. What this can do? The sodium can donate its 1 valency electron to chlorine. Does the chlorine and sodium form a bond with a stable electronic configuration? The chlorine would have got 8 valency electrons and sodium, the before electronic configuration will be filled, right? So in the case of other molecule like Cl2, H2, fluorine, etc., the bond is formed by the sharing of pair of electrons between the atoms. In the process, each atom attains a stable outer electronic configuration. And next we will see about Lewis symbol. Okay, in the formation of a molecule, only the outer shell electrons take part in chemical combination. They are known as valency electrons. We know that valency electrons are nothing but the outer shell electrons. Okay, we know the inner shell electrons will not participate in any of the reactions, in any of the bond formation. Only the valency electrons will play its role, isn't it? So the valency electrons which involve in the formation of a molecule is called the outer shell electrons. Okay, the inner shell electrons are well protected and they will not generally involve in any of the combination process. So what did Lewis do? He represented a notation called Lewis symbol. Okay, where the dots above the symbol will indicate the valency electron. For example, lithium has 1 valency electron, beryllium has 2 valency electron, boron has 3 valency electron, carbon has 4 valency electron, nitrogen has 5 valency electron, oxygen has 6 valency electron. These are all the outer shell electrons. Okay, symbol and the dots represents valency electrons. So neon is a noble gas, isn't it? See, it has 8 electrons. Okay, if it is 8 means it is an octet, it has octet electronic configuration, it is very stable. Okay, let us see about the significance of Lewis symbol. As I already discussed, the number of dots around the symbol represents the number of valence electrons, and this number of valence electrons will help us to calculate the common or group valency of an element. Okay, the group valency of the element is generally either equal to the number of dots in Lewis symbol or just 8 minus the dots of the valency electrons. Next is in relation to chemical bond drew attention to the following facts. Highly electronegative halogens and the highly positive alkali metals are separated by the noble gas. The formation of a negative ion from a halogen atom and a positive ion from an alkali metal atom is associated with the gain and the loss of an electron by the respective atoms. The negative and positive ion thus formed attain stable noble gas electronic configuration. The noble gases, with the exception of helium, which has a doublet of electrons, have a particularly stable outer shell configuration of 8 octet electrons, that is Ns2 and then Np6. The negative and positive ions are stabilized by electrostatic attraction. So what did he do? See, always, the electronegative halogens will form a negative sign, and the electropositive alkali metals will always get a positive sign, and they both can um, join together using the electrostatic attraction which takes place by the sharing of electrons, and thus a chemical bond can be formed. Always the octet electronic configuration holding atoms will not take part in any of the chemical reactions or in any of the bond formation, thus we call it as the noble gases. This is an example of sodium chloride and calcium fluoride. So sodium has one electron, Cna plus, okay, and chlorine is needs one electron, so it is Cl minus. So this excess electron from the sodium can be given to electron deficit chloride atom so that NaCl bond can be formed. Okay, and next one is calcium fluoride. Calcium is having an excess of 2 electrons. Fluorine need only 1 electron. Okay, this calcium 2 electrons from the calcium will goes, 1 electron will goes to one of the fluorine and the other electron will goes to the another fluorine. The CaF2 will be formed, calcium fluoride. Okay, and Kozel, in relation to chemical bonding, drew attention to the following facts. The bond formed as a result of electrostatic attraction between positive and negative ions are termed as electrovalent bond. Okay, if a bond is formed by the electrostatic attraction between the positive and negative ions are called the electrovalent bond. Okay, and always, it holds the number of unit charges. If it is calcium means Ca2 plus, means it can donate 2 electrons. If fluorine means F minus. Okay, minus means it needs 1 electron. Minus 2 means it needs 2 electron. Minus 3 means it needs 3 electrons. For example, Al3 plus. So aluminum is having an excess of 3 electrons. It can donate to the other atoms. Okay, thus calcium is assigned a positive electrovalent of 2, while chlorine and negative electrovalent of 1. Kossel postulations provided the basis of the, he posted all the basis of the basis for the modern concept for the iron crystalline compounds, formation of iron crystalline compounds. And his views has proven to be a great value in understanding and systematic of ionic compounds. But on the same thing, it don't fit to large number of compounds. Thank you.